Question number 17. At a given instant, there are 25% undecayed radioactive nucleus in a sample. After 10 seconds, the number of the undecayed nucleus reduces to 12.5%. Then calculate the mean life of the nucleus, and B part, the time in which the number of undecayed nucleus will further be reduced to 6.25% of the reduced number. So now this one is a very simple problem if you look from the perspective of radioactivity. So radioactivity follows first order chemical kinetics. So from the given information, it is clear that the half-life of the radioactive nucleus is 10 seconds. Since half the amount is consumed in 10 seconds, that is 12.5% is half of 25%. So over here I can say that the half-life or T half can be written as 10 seconds. Now from here we can calculate mean life. So the problem is asking us to calculate mean life. So the value of mean life tau can be calculated as 1 by lambda. Now the value of lambda can be written as 0.693 upon T half. So if we do the calculation, we obtain it as T half upon 0.693, which is equal to 10 upon 0.693, that is equal to 14.43 seconds. So this is the value of a mean life of the nucleus. Now the question is asking the time in which the number of the undecayed nuclei will further be reduced to 6.25% of the reduced number. So of this reduced number, we want the 6.25% of the reduced number. So if you just look at the problem, you can clearly say that over here the decay is taking place from 25% to 12.5% in 10 seconds. So of this reduced number, it is to decay to 6.25%. So I can say that it will take 3 more half-life. So the answer must be 40 seconds. But for the sake of calculation, I am showing by the formulation of radioactivity. So we can begin it in this way as well. So we begin by writing the working formula. Nt is equal to N0 e to the power minus lambda t. From here I can write that N by N0 equals. So now the question is saying of the reduced to 6.25% of the reduced number. So if I consider the reduced number to be 100, so the question is saying that it is reduced to 6.25 of the reduced number. So this is going to be 6.25% of the reduced number, and we are using the value of lambda as 0.00693 second to the power minus 1. So this is the value of lambda we are using. So if we put this value in this equation, we obtain it as 6.25 by 100 is equal to e to the power minus 0.0693 into t. So from here I can calculate e to the power plus 0.0693 into t is equal to 100 by 6.25, that is equal to 16. From here I can calculate the value of t. So we can write it as 0.0693t is equal to ln 16. So we have taken log on both sides, and from here I can calculate the value of t as 40 seconds. So the value of t will come out to be 40 seconds.